So first type of ensemble theory is microcanonical ensemble. In this type, we study only about the isolated system. So in microcanonical ensemble, we deals only isolated system with fixed total energy, volume and number of particles. Then this type of ensemble theory is called microcanonical ensemble. For example, if we have a box and large number of particles, they are isolated. This means that outside the system or outside the box, the temperature, air or pressure, all these stuff doesn't affect inside the particle. This shows that isolated system. So if the system is isolated and totally packed, then total energy will be conserved, remain same, volume, number of particle will remain same. So this condition show the microcanonical ensemble. In microcanonical ensemble, the system is in state of constant energy. This could be learned in simple word that if a system is isolated and fully protected, then it has only constant energy. If we see in simple word, these three are macroscopic particles and these three are the microscopic particles. If we see this first, second and third, they show that they are macroscopically looks like a large particle, but in microscopic property they looks like small particle. So they are totally isolated. N shows n number of particles. It means walls are impermeable, and V means volume constant. It means walls are rigid. This means that these particles, when strike with the walls of a container, they does not exert force. And in simple term, E means energy constant. It means walls are adiabatic. In adiabatic, as we know, heat doesn't enter, not leave. So this process would be adiabatic. So after the result of these three terms, we have a system which would be isolated system, which means that no external force enter, no external energy enter, not leave. So system will be totally protected. This would be isolated system, which shows the microscopic ensemble. For microscopic ensemble, we have three conditions, that number of particle, volume and energy would be same. If we have another condition, then this would not be a microcanonical ensemble. Microcanonical ensemble, if we see about the example, so the example in detail is, consider a box containing an ideal gas with a fixed number of particles and a fixed total energy. The gas particles are not allowed to exchange energy or matter with the surrounding. The box walls are perfectly insulated, so there is no heat exhaust with the environment. In simple term, the system is adiabatic system. No heat enter, no heat leave, and number of particle, volume will remain the same, energy will remain the same. The system would be isolated. So in this case, result will be in form of microcanonical ensemble. So this is example of microcanonical example because the total energy, volume and number of particle are all fixed. The gas particle can move freely within the box.